So in the last class, we started discussing about inter-process communication. Okay, so there we discussed about concepts like what are the things, basic things we have to understand before proceeding with any of the inter-process communication methods. Okay, so there we discussed about three important topics. One is about the key. Okay, how to generate the key by using identifier. Okay, key is generated by using identifier. Next thing is about the permissions, different types of permissions for inter-process communication, and how to set the configuration limits. Okay, so these are three important things to remember before starting with any inter-process communications. So as discussed already, so there are three important types of inter-process communication. So one is message queue, semaphorous, and shared memory. So these three topics we are going to discuss. Okay, so beginning with the first one. So first we will start discussing about message queue. Okay. So message queue is a linked list of messages stored within the kernel, and each messages are identified by unique identifier in the message queue. Okay, so message queue, you have studied in the data structure what is a queue, correct? So here the queue is a data structure. Okay, so message queue is similar to the normal data structure queue, but here we are going to store the linked list of messages. Okay, and these messages are stored within the kernel. We call that message queue is just a queue. So we can call a message queue simply as a queue, and its identifier is called as a unique queue ID. A new key is created using the API. So we are going to study different APIs or the functions that is related to message queue. Okay, so here the first function is this message get. Okay, so this is used for creating a new message queue or an existing queue to be opened. Okay, so this is the first API. So new messages are added to the end of the queue. Remember, we can add using the API message send, message send. Okay. Then every message has a positive long integer type field. Okay. So every message that you send through the queue will be having a type field. Then it will be having a length field which will tell the length of the message, which is a non-negative number, and the data, actual data that you want to send through the queue, which will be in terms of bytes. Okay, and all of which are specified to this message send when the message is added to the queue. So when you are sending the message, you have to specify all these three fields: type, length of the message, and the data what you want to send through the message queue. Okay, then there is one more, that is message receive. Okay, so this is the API that is used for fetching the message from the queue. Okay, to get the message or to receive the message from the queue, we'll be using the third API. Okay. So one more thing is, we need not fetch the message in first out order. Okay. So for inter-process communication between the two processes, okay, we can use this message queue. Okay, this message queue can be used for inter-process communication. As you send the message through the message queue, they need not be fetched in first out. Okay, this is what you have studied, right? In first in data structure, first in first out order. Okay, so that is not necessary. Instead, we can fetch the message based on their type field. Okay, so based on the type field, we can give the priority to the message, and based on that, you can fetch any of the message. Okay, then next one is each queue has the following message queue ID. Okay, DS. So this is the structure. Okay, so each message queue will be having this okay data structure associated with it. Okay, the structure you can see. Okay, the name of the structure is MSQ. Okay, message QID underscore DS. Okay, defines the current status of the message queue. So this will give you the exact status of the message queue. So you can see we have different fields here. Okay, so this we will discuss. This is the first field is a in turn it's a structure. Okay, we will discuss later. Okay, second one is a structure with the name message first. Okay, so this is a structure which is a pointer. Okay, so this is a pointer to the first message on the queue. So this will be pointing to the first message on the queue, and similarly the next one is a pointer and it will be pointing to the last message on the queue. Okay, so again you have different other fields. Okay, like queue number. So queue number will give you number of messages on the queue, then will give you queue bytes, will give you maximum number of bytes on the queue. Okay, similarly we have message LSPID. So that is a ID, okay, of the last message that is being sent, and next one the last message that has been received. Okay, similarly we have three time. Okay, so there are three time fields. Okay, so this is a time which will tell you the last message received time. Okay, send time. Okay, and this will give you the last message received time and last change time if there is any changes done, okay, to the message queue, which will give you the modification time. Okay, when the last modification is done to the queue. So these are some of the fields that comes under this data structure. Okay, so all these fields are self-defining. Okay, so let us first start discussing the first function. Okay, so that is this first function. Okay, so that is used for either opening an existing queue or for creating a new message queue. So this is the first function. Okay, and you can see there are two fields here. One is the key, another one is a flag. Okay, so this, if you are able to create or if you are successfully able to open the message queue, then it will return you the message queue ID. Okay, or else if there is any failure, then it will return -1. Okay, then the rules for converting, we know that this key should be converted into an identifier, correct? So previous class we discussed, okay, the key that is shared should be converted into an identifier. Okay, so for converting this key to an identifier, we need to follow few rules. Okay. Then when a new key is created, the following members of this message uh, IDDS structures are initialized. Okay, you can see here there are different members. Out of that, few of the members, okay, will be initialized when you create the queue. What are those members? So first one is the structure IPC underscore PERM structure will be initialized. Where you can find the structure It is here. Okay, so that is a first field. Okay, so this is a first thing will be initialized. Okay, so IPC, okay, underscore PERM stands for permission. Okay, so permission will be initialized. You can see here they have already discussed that structure here. Okay, this is that structure. So this structure will be having this UID, GIDs, permission, all the permissions. Okay, and even you have this mode field. So this mode member of the structure is set to the corresponding permission bit of a flag. Okay. You can see here. Okay. Then what are the other members? Next one is message queue number. Okay, message LS ID. All these fields will be set to 0 initially when you create this message queue first time when you create. Okay, all this field, whatever you can see here, time, okay, LS, RS, everything will be set to 0. Okay, and C times. What is the C time? So C time is a changing time will be set to the current time. So initially we are not performing any modification. So this change time will be set to okay current system time. Okay, next one more thing is Q byte. What is this Q byte? So Q byte will give you the maximum number of bytes on the queue. Okay, so this will be set to the system limit value. Okay, every system will have their own limit for sending the data through the message queue. Okay, so this queue limit will be set to some system specified value. Just for example, of 500 MB. So only 500 MB data you can send through message queue for inter-process communication. Okay, so these are the values will be initialized when you initially create the message queue. Okay, so on success it will return you the message queue ID, which is non value. Okay, and whatever this ID that you get, okay, whatever the ID that you get will be used by other two functions. Okay, you can see here we have other two functions, message send and message receive, right? So once you get the ID from this, okay, that message queue ID will be used by these other functions. Okay, so that message ID is very important. Yeah. Next, we'll be discussing other three functions. One is message control, message send, and message receive. Okay, so all these three message queue functions will be using this ID. Okay, so first we'll discuss about the first function, that is message CTL. So message CTL performs various operations on the queue. Okay, so various operations might be deleting some messages or adding some new messages or performing some modifications. Okay, some different operations will be performed on the queue. So this is this prototype. Okay, so this is a message queue ID which you get from here. Okay, I said you are using the ID, so that is this ID, message ID. Okay, other than that there are different other fields like command. Okay, there is a buffer, okay, which is a pointer. Okay, so let's discuss this. So first is a message ID, okay, which you get from get after executing this message get function. Okay, so that is ID, message queue ID. This is done. Next argument is CMD. So CMD specifies a command to be performed on the queue specified by the message queue ID. The command to be performed. So here in this below table, you can see different commands. Okay, we have, these are different names of the commands. So the first one is RMID. So this is the first command we'll discuss. So what does this command will do? So this command removes the message queue from the system. So what operation it will do? If you are executing, if you are writing this command, okay, then what it will do? It will remove the message queue from the system and all the data still on the message queue. So it will destroy the entire message queue structure. Okay, this removal is immediate, or any other process still using the message queue will get the error message. Okay, if any queue after, okay, or using this message queue, any process is using this message queue, they will get the error message. Okay, so this command can be executed only by the process whose effective user ID is equal to the, okay, they should have this permission. Okay, they should have the effective user ID permission, or they should have the super user permission or root user permission. Only if you have root user permission or certain permission, then only you can execute this command for removing the message queue. Okay, next one is IP set. Okay, so next command sets the following 4 field from the structure pointed by the buffer. So you can see there is a pointer, okay, with the name buff. Okay, using this pointer you can set 4 fields. So set the member of the data structure, okay, from buff. Okay, what are those fields? So we can set, what are the 4 fields? We can set this. First one is through this structure. Okay, through this structure you can set this UID. We can change and set the new UID. Okay, and you can set GID. Okay, and you can set mode. Okay, mode is nothing but the permission, what read or write permission, and Q byte. Okay, message Q byte. That is this field. Okay, maximum number of bytes on the queue. So these 4 fields you can set using this second command. Okay. And similarly for this also, to execute this command, okay, you need certain amount of permissions. Only if you have the root permission or super user permission, you can change the value of this. Okay, that is this maximum number of queue on the byte, you can change that. And the last field is, last command is IPC stat. Okay, so this will fetch the structure for this queue, okay, storing it in the structure pointed by the buffer. So this is copying the member of the, what are the members that we have here? Okay, all these members, copy the member of the data structure into the buffer. So all the structure that we have discussed here, okay, all the time, or pointers, all permissions, mode, everything will be copied to this buffer. Okay. So this is about the second argument, that is command argument. Next we will discuss about the next API, that is message send. Okay. The data is placed on the queue, that is message queue, by calling this function, that is message queue. Okay, so data is placed on the message queue using this function. So as I already said, we need the message queue ID. Okay, apart from that, we have 3 more parameters or arguments, one pointer, n bytes, and one more is flag. Okay. Here whatever the message that you send will be copied to the end of the message queue. Okay, so each message will be having type field. Okay, they will be having the length field, and they will be having the number of actual data that you are sending. Maybe the limit may be around 500 MB. Okay, maximum limit you are going to send how much actual bytes of data, maybe 200 KB. Okay, so that is actual data, how much you are going to send in terms of bytes. Okay, then there is next one argument, that is PTR argument. So PTR points to the long integer that is a positive integer message type. Okay, and it is immediately followed by the message data. So here where it is pointing to the, okay, the message type. It is pointing to the message type. Immediately after the message, what you are having the actual message data. What you have said here, 200K message type. Okay. Message is well, we can define for picture. Okay, so this is the picture that you're going to send. Okay, so here there are two fields. Okay, one is the type field, another one is that the structure for holding the data that you are going to send. So that PTR will be pointer to this structure. So this pointer, okay, PTR will be pointing to this structure, which will be having two things. One is type of the message that you're going to send, and the actual message data, how much bytes of data you're going to send. Okay, in this example, it is 512 bytes. Okay. Then apart from that, you are having a flag value. Okay, so for this flag we are having different constant values. Okay, so we will not worry about that in detail. Okay, so there are different values that are available. The next one is the messages are received from the queue using message receive function. So this is the next function we are using for receiving the message. Okay, here also we are using queue IDs, pointer, the bytes and type field, and what type of data you're going to receive, and the flag field. So many things are, so many arguments we have here. Okay, and here as in the send, okay, as in send you are having a pointer, correct? Similar to here also we are having this pointer, and this pointer is similar to that previous one. Okay, and here on success, okay, on success execution of this message, it will give you the size of data portion of the message, how much portion of data you have received from the queue, how much, around I mean 512 bytes or 200 KB, whatever the message amount of data you have received from the queue. So that will be given, or you will be receiving -1 on error. Okay, and here you have type field. So this type field will be having three different values. So what are those values? So first, if it is equal to 0, then the first message on the queue is returned. So you are getting the first message. Okay, greater than 0 means the first message on the queue whose message type is equal to the message type returned. Okay, so you are getting the expected message type. Okay, you are asking for certain type of message, and you are getting the same type of message. Okay, JPEG message type, you also receive same type of message. Okay, less than 0, when less than 0, the first message on the queue whose message type is lowest value less than or equal to the absolute value of the type. That means the type you are asking, okay, sent here, okay, are different from that of the type that you have received. Okay, so this is all about uh, different functions. Sometimes you may get a question, explain the concept of message queue and explain all the functions that we are using in message queue. Okay, we don't have any programs here in the textbook. Okay, we just have the prototype of all the functions that we are using in the message queue. Okay, so this is about message queue. Okay. I have uploaded one class test paper in Teams. Okay. Just once you check whether you are able to access that paper, class test paper. Today I have uploaded just now. A while back I have uploaded. Are you able to access?
Yes, ma'am.
Yes.
Uh, there are 3 questions, okay, which belongs to module 5. Okay, please take the test. Okay, once you done with the test, upload that in the Teams. Okay, is that clear?
Yes, ma'am.
Okay, fine. Start.